All right. Hey, don't forget your dual enrollment. If you're doing it, it's due next Friday. Either like your payment and your application thing or whatever. So they're not going to take it late. So fill that out.
Yes.
Well, there we go. I'll take our notes, but you can do it when you still work. Doesn't matter. I mean, it's not like it's like an essay or something.
Yeah, very good. It's 49 last year.
Alright, so you guys want a midterm or you want corrections? This table? Midterm or corrections? This table? This table? This table? Yeah.
Alright, well, we already have 3. Majority wins. You guys are already
Oh,
lost.
yeah, I mean, the syllabus said we were going to have a midterm, so I'll do that if, you know.
Just give them the midterm. Yeah, give them the midterm.
Alright, they're holding out, so we can just give them a stink eye for a while, alright? That's okay. Alright, it's okay. Alright, so let's look at this one last problem on here. So remember, letter A we did by just plugging in. Letter B we did by factoring. Letter C we did by multiplying by the conjugate, radical x plus 3. Alright, and canceling. And then this one right here, sometimes you have to like literally just do some algebra. Like I can't plug 0 into here now because it creates 0 over 0. I don't really want to do L'Hopital's rule because the top, 1 over h plus 5 would be annoying to do the derivative of. So why don't we just do some algebra? Like for instance on the top, why don't we get a common what? Denominator. So if I did that, it would be 5 and h plus 5 on the bottom. What would the first one, what would this one right here turn into? Because I'm putting this common denominator. 5, because I had to give a 5 to that, so you turn to a 5 minus, what would this part be? Become h plus 5. But remember, this minus goes for all of it, so h plus 5 like that. All right, so then what happens on the top? Yeah, you get negative h, right? So the 5s go away, because 5 minus 5, you get a negative h. So what that turns into, I'm supposed to be writing limit, but I'm not. I get a negative h on top. On the bottom, I have a 5 and an h plus 5. And this is all divided by h. But divided by h means it's times 1 over h, right? Okay, so then these h's go away, and that's what I was needing to happen. And so now when I do my limit, as h goes to 0, I can go ahead and say the top is negative 1. If I put a 0 down here, I get 5 times 5, so I get 25, right? So I can go ahead and do it. So that the h canceling, that's what I always, this is a lot of those derivative limits you did before. So anyway, all these things that you've done with limits before, we're going to also do with limits, but they're going to be like, you don't have to turn the page, but like, look how there's x and y is like mixed together. Like you're gonna have to do some of this stuff. You're gonna have to factor. You're gonna have to maybe multiply by the conjugate. You're gonna have to like maybe separate. Like we didn't do all the tricks or whatever right here. Or sometimes you can look at a graph, but not really that helpful in these situations. But I'll show you some graphs just to like prove the answers to you, but like you can't really tell the answer from the graph that good. All right. So remember the definition of continuity. All right. You have to have your function defined at the place that you're looking at. The limit has to exist, and the limit has to equal what? The value of the function, right? It has to equal f of xy. Or I guess I should say ab. Sorry, not xy. So f of ab. So those three things, that's when something's continuous. So some of these questions are like about continuity, but most at the beginning we're going to do about limits. Okay? All right, so let's dig in. Now some of the ones that you're going to do, they're going to be like a very simple like algebra type thing to do. All right, So, for instance, like, is there a problem with plugging 1 and 2 in for x and y in this problem? No, like I'm going to get a number on the, so by problem I mean is the bottom going to be 0, like that's a problem, right? But no, like, let's just plug in 1 and 2. So if I just plug it in, right? So I get 4 times 1 times 2 on the top. On the bottom I get 3 times 1 squared plus 2 squared, so plus 4. Okay, so I get 8 over 7. Okay? Alright, so that 4xy right there over 3x squared plus y squared. Nobody expects you to know like what that looks like, but if you were to inspect it, this is what that thing looks like, right? Like it's this little like a sheet or whatever, like kind of like a plane with like a bunch of some curves to it, right? Everybody good? So if I graph this point right here, so you see that point, like the limit is that because it's just sitting nice and pretty. It's just that place on the graph. Everybody good? All right, so as your x and y values approach the numbers 1 and 2, the z value, remember, like the f of x, y is z, the z approaches 8/7, okay? And that's all you're finding out. Now, this thing, these pictures, do you see these weird, like, this weird, like, dip thing right here, like right in this corner? And then on the other side, that one too. That's where these graphs, like, tend to have problems. But we were doing it at, like, just like a nice coordinate. But like when you dip into that like weird hole right there, sometimes you can't do the limit there, and so that's what some of the other ones end up doing. Okay. All right. So let's look at the next one, letter B. Do you guys remember that in calculus last year, when somebody would ask you the limit as x goes to 0? And you have like sine x over x. Remember you like memorized that one?
Yeah.
That was like 1, right? And there was also like x over cosine or something, or there was a cosine one, but I forget. Anyway, yeah, maybe tan x over x. Is that one also? Or is that 0? I forget, but there's this one, okay? So, if I go right now, then you should always try to like plug in the numbers first, right? Like if I plug in 0 and 1. But when I plug 0 in for x, I get 0 on top and 0 on bottom, so that ruins it, right? And so we can't really do L'Hopital's rule in this situation because it has x. I mean, you can, but it's just hard. It has x and y. Maybe you don't know how to do that yet, right? The derivatives with respect to x or y. You know, that's like next section. So what we could also do is this. So sometimes if you want to, you can separate this. Like I can easily separate this into my limit. God, why is this not going? I could separate this into, into 2 problems. Let's do my limit as x, y goes to 0, 1. And let's pull apart, let's take the sine x over here, over x, times, and I could do another limit over here, as x, y goes to 0, 1. And I could just leave the y over y plus 1. So this is the same problem. I'm just like separating into 2 problems, 2 things. But you see how this question right here, this problem is kind of separable like that, like separated with multiplication. All right. So now if I plug in 0, this involves x. So if I plug 0 into here, I get that old answer that I talked about it here is 1. And now there's no problem. What do I plug into all these y's? It's 1. So I get 1/2. Right? So 1 times 1/2 is 1/2. And so sometimes you have to use a trick of like, oh, let's separate it. Right? And then on letter C, what do you think I could do to help myself out on letter C? Factor. Yes, like a factor, right? Y squared minus 4 turns into y plus 2 and y minus 2. And on the bottom, what can I pull out to factor? An x. So x, and then the y minus 2 is left. And so that right there, that was the thing that was causing the problem. All right, because it was creating a 0 on top and a 0 on bottom. So now when I do my limit, xy to 2. And now when I plug in my 2's, I'm perfectly fine. I get 4 on top and on bottom 2. So 4 over 2 is just All right, so on letter D. On letter D, I have 1 minus cosine and then x and then y squared. So there's no factoring to do, but I could write it like this. I could have 1 minus cosine. So right now, if I plug in 0 for y, the top is 1 minus 1, cosine of 0 is 1, and the bottom is 0. So like I'm getting 0 over 0 is the issue here. All right, but if I do this and then have my y squared there, let's try that. And then I could do the 1 over x over here. Is that okay? If I separate those? Like, all I did was like pull the x over there. Is that fine? Okay, yeah, it's still bad, but you're okay with what I did. All right. So you can then use L'Hopital's. Once you separate them, you can use like L'Hopital's on this now. This one's fine. That's going to be, you're going to plug in a 2, you're going to get 1/2. But you can go forward and do L'Hopital's on this one because you're still getting 0 over 0. So tell someone, hey, I'm doing L'Hopital's rule. Yes, yes. All right. So if I do L'Hopital's on that, the derivative of 1 is 0. What's the derivative of my negative cosine?
Negative sign.
Negative sign, so it'll turn into plus. So just turn the sign, right? Because its derivative is negative sign, but there's already a negative, so it'll just be sine. So sine y. And on the bottom, what's the derivative of
2y.
Yeah, 2y. All right. Remember, I'm plugging in 0 for y, so it's still bad, right? If I plug in, I got to do it again. So this is still 0 over 0, so we'll just do L'Hopital's again. And finally, we'll get it to be okay. So derivative of sine is your cosine. And then 2 on the bottom. So yeah, now when I plug in 0, I get 1/2. So I end up having 1/2 times 1/2, so 1/4. Okay. So once it's separate, then you can do your L'Hopital's a little better. Everybody good? All right, so flip the page. Now come the bad ones. Yes. Okay. All right. So you remember on the little warm up when we looked at this question here, your limit has to match from every direction. When we're two-dimensional, all we have is the left side and the right side. That's the only direction I can come at you with. All right. But when you're three-dimension, like if I say, I'm going to put like a ball here or something. I want you guys to come at this like basketball or something. You can come in like literally like 100 million directions. Right? You come at it in any direction. All right. So we're going to have one specific kind of directions that we're going to try first. And basically what we're looking for is we're kind of looking for a mismatch. When you come at it one direction, the limit is one thing. When you come at it another direction, the limit is another thing. And then, hey, I get a mismatch and then it doesn't work. Okay, so most of these, like a lot of times, it does not exist because you're kind of looking for things that like mismatch, and then you're like, okay, it's done. Okay, all right. So let me show you a picture of this one first. So, let's screw this up. Answer had to agree from the left and the right side. All right. So now your 3D, so the limit has to agree from every direction. Oh. Okay. All right, so let's look at this one real quick. X plus 2y and x minus 2y. So if we look at that graph, so here's the graph of that one. So you see it's like pretty weird. All right, so nobody's going to ask you to like graph these things. Okay, but let me show you what we're about to do. We're about to come at this. You can come at it like and from any like line basically. So we're going to come at it from the line x equals 0. All right, like the plane basically x equals 0. So do you see when I turn on x equals 0? Do you see that they intersect? Like, so whatever, you see that. And so then when I turn on y equals 0, so look right here. Do you see that y equals 0 is like intersecting up here? and x equals 0 is intersecting down here, they're not meshing up. They're not coming into the same place. All right? So we're going to see that, and it's going to be a fail. It's going to be a does not exist. So when I come at this orange thing from different ways, I intersect it at 1 when I use y equals 0. And then you're going to see I'm going to intersect it at -1 when I use x equals 0. And it's going to be not intersecting the same place. All right? So that's what it looks like. I mean, I don't know if it helps you to see it, but whatever. That's that. Okay. All right. So x equals 0 and y equals 0 are two of the first things that you're going to try. All right. So this is how it goes. So you're going to say to someone, "I'm going to try this." You're going to let x equals 0. So you have a problem, and also notice this. This doesn't factor. There's no algebra that I could do to this to help myself. I couldn't separate it or anything like that. All right. So when I let x equal 0, so what I'm doing is I'm letting x be 0. So basically, I have a limit with only y's left. So I'm doing a limit as y still goes to 0, because that's what it said earlier. And if x is 0, what has my problem become? 2y over -2y. So the y's cancel, and what's my limit for my answer? -1. All right, so great. And you can kind of see that in the picture a little bit. And then over here, when I if I let x equals 0, or y equals 0, so that means that I'm going to travel along the plane y equals 0, and I'm coming at the curve, and I'm walking over to it, and I'm like, oh, where am I when I hit the curve, right? So if I let y equals 0, then my limit is x going to this 0 right here. And if y equals 0, I get x over x. So those cancel out, and I just get what? 1. And so this mismatch is what I was looking for. I mean, obviously I was looking for it to match, but usually in these problems, you get a mismatch, right? All right, so yeah, Danny, they don't agree. So this limit does not exist. There must be something weird going on there that doesn't exist. So when you get a mismatch like that, it doesn't exist. Okay. All right. So look at this column here. Is there anything that I can do to separate this that would be helpful? Because the top is multiplied. So maybe I could separate it into x squared over something and then y squared over something. But look at the bottom, it's added. I can't separate the bottom, right? Grace, you gonna make it? All right, come on, give yourself a slap or something. You had 4 days off from math. You can take it. All right. So I can't separate it. I can't do anything, right? Jason, with us? Got a golf game today? No. Is golf over?
Yeah.
Oh, sad.
No, I got the car.
Oh. All right. So let's try the same thing that we did before. So let's try x equals 0. So if x equals 0, then basically what I get under my limit as y goes to 0. So if x equals 0, though, I end up getting 0 over y to the 4th. So what's the limit of that? 0. So that doesn't help that much because I'm about to get the same thing. And I get, if I do y equals 0, I have my limit as x goes to 0. I'm going to do x goes to 0 because that's what x says. All right? And I basically get 0 over x squared. That's also 0. You're like, oh, yay, it matches. I'm done. 0. No, you're not. Okay? All right. So we have to try quite a few other things here. And I think I have a picture of this one, too. This is the last picture I have. But let me just show it to you, since I have it. All right. So here's the graph of the thing that we're looking at right now. All right. So what we're trying to do you see on this picture? Do you see these things? And do you remember, like it's oscillating? You see these curves right in the middle. It's hard to see, but there's breaks in them because this graph is bouncing back and forth. And remember how when graphs, usually it was sine graphs and sine or something weird. Remember the curve bounces back and forth? And any particular moment, if you stop here, your graph might be up there. But then just a second later, it's down here. And so like which one is better? It keeps bouncing back and forth, and when your graph oscillated, the limit didn't exist because you could pick anything at a particular moment. And so it's hard to see, but that's what that graph is doing right there. It's like it's jumping back and forth. You see the ridges kind of? Oh, okay, but you can see it. Like you get the idea of what I'm saying, right? See them? Do you see them now? Iris.
Yes.
Okay, would you totally zoom in and then you don't see anything? Okay. But you see how the little ridges right there? So it's oscillating, all right? All right. So we're about to get that this thing doesn't exist, and we're trying to do the limit at the origin right here, basically. All right. But it works. All right. So we're going to try a bunch of different things. We're going to try y equals x. We're going to try y equals x squared. Like the parabola, we're going to try it that way. So if I move it, so we're going to try coming at it with a little paraboloid thing right there. And then we're going to try x equals y squared. Now look, you can kind of see it here. Do you see how the green and the red things, they don't, at this place, they're not meeting up. The green and the red are not meeting up this place. That's why we're going to get it. It's not going to work. Because the green and red, if they met up at the same place, we're going to be like, oh, that's the answer. But when you come at it, when I come at this purple thing along this green and I come towards 0, I'm over here. But when I come at it on the red thing, I'm down here. And so it's like not going to match up. All right. Okay, so let's do this one, then we'll take a break for a couple minutes, all right? Oh, that's all you love, huh? Great. Look, we got a 3-day weekend this weekend. Monday I have to come here and go to some super fun meetings. I mean, come on. Equity, come on. Equity.
What's our answer? Does not exist.
All right. Have I ever been not equitable too long? Oh my God. All right, so let's try some more. So you don't just do x equals 0 and y equals 0. Maybe you come at it. Let's do, we're going to let y equals x. So you do exactly that. If you're letting y be x, then all you have left is x's. So you're doing your limit. You're allowed to do anything. Oh my God, I think it's correct. Alright, give me a second. Alright, so if I'm letting y be x, I'm doing my limit then as x goes to 0 still. Alright, so all my y's have now turned to x's. So what do I have on top? X to the third, right? Because these y's became x's, so it's x squared times x. And on bottom, I have x squared. Hang on a second. I have x squared plus x to the fourth. I can't, what the, I can't, so I'm trying to record this for Anna. And she can't see it now. Just, all right, take a break right now for a second. I'm going to restart this thing. Take a break. Maybe these things are better. I'm gonna find some left there. I was like, I'm not saying
6 over 26. so it's just like saying what's one is 0. That's y plus 0. So then what about this next?
It's like 50. Only 11 down. I still know what it is later.
Just the bottom goes past the top. When you find 0, it's 0.
Alright, ready? We're having a little break here, maybe. Let's see. Alright, so we're doing x, y equals x. So on the bottom I'd have x squared plus y, plus x to the 4th. Alright. So, let's see. So this one, you're going to have to imagine what's happening a little bit. But do you notice how, like, the top has a smaller degree than the bottom, right? So if I kept doing L'Hopital's, which problem would turn into a constant first? The top is x to the 3rd, the bottom is x to the 4th. X to the 4th. Can you see this, like, right here?
Oh, yeah.
Alright, so, if I did this one right here, if I imagine that graph right there, as I go to 0, oh, let's see. Well, I still can't do it. Okay, so let me just do this one time, then we'll just know forever. Let's do L'Hopital's, right? So if I did L'Hopital's once, I would get 3x squared. The bottom, I would get 2x plus 4x to the 3rd. Everybody good? Alright, it's still 0 over 0, so let's do it again. So, if I did L'Hopital's now, I would have 6x, but look at this 2 right here. This turns into a 2 plus 12x squared. You follow? Alright, so now when I plug 0 in, the top is 0, but what's the bottom? 2. Because I get, yeah, so 0 over 2, and that's okay. That's just 0. Okay? So, you have to kind of think of that in your head a little bit, but like, you know, you start to see, oh wait, this x squared is going to become a number eventually, and that'll take care of the 0 on the bottom, so I'll have 0 on top and a number on the bottom. Alright, so that one was 0. So I'm like happy, I'm like, oh wow, this is looking great. Okay, so let's try 2 more things. Let's let y equals x squared. We're also going to let x equals y squared. So 2 different parabolas we're coming in on.
Why are we just doing this just because? Or like?
Well, you saw in the picture, like, it's not supposed to work, but it keeps making 0. So let me finish and show you. So I'll give you like a list of like, if you try these 5 things and it all matches, then we'll just trust it. All right. But, you know, at this point, like, this is going to be the 5th thing over here. So if you try all 5 and it works, we'll be like, okay, I've tried enough. I can't sit here all day. All right.
So we have to try all 5 to see if it works.
Right. But no, I'm saying, but if you get a fail earlier, then stop. Like, look, this one failed after the first 2 things. I can stop. But look, I keep getting 0. Like, this is a match still. Yes, right. All right. But if after you try the 5 things, then and you still got all matches, we'll just stop and say it's good. All right. So y equals x squared. So all these y's are now x squared. So imagine what that would do. I'm going to have x times, if I put an x squared in place of the y, it's going to be x squared squared, so x to the 4th. So it's going to be x to the 5th. The bottom is going to be x squared plus, and then y to the 4th. So I'd have an x squared to the 4th power, so that'd be x to the 8th. All right, so let's put our limit back. Alright, so the same thing that happened to us earlier, we would use L'Hopital's rule. If I use L'Hopital's, what's going to become a number first? The x squared is going to become a number eventually. And I'll have 0 over 2 again. So, oh yeah, sure, you could do that. And then cancel some. But eventually it would do the same thing that this one did. Right. But if I kept doing, yes. So what this has said is you could, cancel out some x's. You could. But, oh, did I say your, sorry. Did I say your father's name? I'm sorry. I got confused. I don't know how I like you guys. Anyway. Alright. So, anyway, same thing's going to happen here. I'm going to get 0 because I'm going to basically go back to that. Okay? Alright, so let's try this last one. So, my limit as x, y goes to 0, 0. Going to right, I know. We're letting x equals y squared. So on top, I'm going to have y to the second times y to the second, so y to the fourth. All right, on bottom, remember the x's are y squared. So on the bottom, I'm going to have a y squared squared, so it's going to be y to the fourth plus y to the fourth. So these all match. So I'm going to get y to the fourth over 2y to the fourth, and what happens to the y to the fourths? They cancel. So I end up getting a 1/2 there. This is what I'm doing my limit of. Right, goes to 0, 0. So that is 1/2. And that right there is my fail. All right? So, therefore, D&E. Okay? So, this is the annoying part. All right? So, you do this one right here. You do this one. All right? Start with x equals 0 and y equals 0. Did we already do this one? No.
There's no way. Oh, no,
So, oh, you're right. You're right. So, I messed up back here a little bit in my notation. Back here, we were letting y be x squared, so all we have left are x's. So I should not have written the whole xy part right here. So this should have just been x goes to 0. And this part too should have been y. Sorry about that. Thank you. Thanks, sorry about that. Alright, so you try that first one over on the left. Try x equals 0 and y equals 0 to start with.
Oh, we're doing this on our own?
Yes.
It's not actually more.
Oh, it already fell. Oh,
There it is. What is
Keep going.
Alright. So you got one negative one on that? Is that okay? Alright, let's try this one over here. So, you can kind of look at the problem and say this. If you do x equals 0 and y equals 0, what's going to happen to the top in both cases? It's going to be 0 on top, right? We can have 0 on top over like an x to the fourth. So that would be 0 also. But if I kept doing L'Hopital's rule, that x to the fourth would eventually become a constant, right? But the top would still be 0. So 0 over a constant is going to be 0. All right. If I did y equals 0, the top would be 0. And the same thing would happen to the bottom. I would have, I'm sorry, I switched these around, but I'd have the x to the fourth. It would become a constant eventually. So these will both be 0. So as you get better at it, you kind of look to it and be like, oh, I'm going to get 0 for those. It's not that helpful. All right. So we're going to do this last one here. Let's do y equals x squared. Okay. You could. I'm just doing y equals x squared. All right. So if y equals x squared, that means my limit is only for x going to 0 right now. So all the y's are x squared. So I'm going to have an x squared and another x squared. So x to the fourth, e to the x squared. Everybody okay? On the bottom, I'd have x to the fourth plus 4. If y is x squared squared would be x to the fourth. All right. So you see how all the x to the fourths can cancel out? So I have e to the x squared over 5. Is everybody okay with that? All right. So my limit as x goes to 0 of this, yes, I put 0 in, I'm going to get a 1/5. So that doesn't match my 0, so it does not exist. No, you have to show. All right, now, there is another one that you can try. You can try coming at it at a line with any kind of slope. So you'll do that one as a last resort, but usually you'll get a DNE by the time you get there, so you don't have to worry about it. These are the ones you're going to test. You got x equals 0, y equals 0, y equals x squared, x equals y squared, and you got y equals x. So if you can test all those 5 and it's fine, then you go for it. There's also another one you could do, you can do another line or another plane. You can do y equals mx. And the mx just leaves a random slope in there for your plane. So sometimes that helps because sometimes the slope of 1 doesn't really do everything. The 1 just kind of disappears. But you don't really have to do y equals mx. All right, almost done here. So let's see what we got there. All right, that's it, right? Pretty good? Okay. Okay, so we already did this problem earlier, if I remember right. Let's look for it. Did we? Crap. Did we not? Okay, we didn't, but whatever. All right. All right. So remember, to be continuous, your function has to exist. Your limit has to match the function value at that place. So if I try to plug in, there's obviously a hole here at 0, because if you try to plug in zeros for the x and y, I can't do it, right? But then somebody is giving me a piecewise function that tells me that. They tell me, oh, well, it's 0 when x and y are 0. So they've defined it for me. So is it defined? Yes. Defined at 0, 0. Yes. So let's check if the limit exists. Limit exists. All right. So let's check and see. Okay. So will you trust me that if I do all the things, my limit is equal to 0? Will you trust me? We'll try a few. All right. Thanks. Let's do x equals 0. If x equals 0, then I basically get 0 over y squared. So that's 0. If y equals 0, then I also get 0 over x squared. So that's just 0. What about if I do y equals x?
0.
So I would get 3x to the third over, if y equals x, down here I'm going to get x squared plus x squared, so 2x squared. So basically I'd have 3x over 2. And if I put 0 into that, I get 0.
Guess the next one.
So they're all 0. Okay? So the limit exists? Yes, it does. And it's equal to 0. So this limit is 0 and it's defined to be 0. So is this continuous?
Yes.
Yes. Alright, so like you would have to try a few more, but we did. Alright, now this one you definitely did earlier. So remember I made you do this one on the last page? What did you get for that limit? Right. Because you gotta, when you let x be 0, you got a -1. When you let y be 0, you got a +1, right? So limit does not exist. Okay, so is it continuous?
No.
No, it's defined, like everything's there, but no. So not continuous. Because the limit didn't exist. So like one of our 3 rules like wasn't good.
The limits didn't count. Oh, really?
Remember you did that problem, I made you do it like right here.
Oh, yeah.
Alright, so last one right here. Let's just do a little where this thing is continuous. So if you want this to be continuous right here, what did we talk about in our homework last night? X minus y has to stay between what? Right. Has to be greater than or equal to -1 and less than or equal to +1. So that's where basically this thing is defined, that's where it's continuous. So you'd want to say that xy such that, so it's like a little set notation. You'd want to have an x and a y value such that x minus y is between -1 and 1. So that's how, yeah. I mean, I could have said xy as an element of the real numbers. I guess I could have put that. So remember that little right there. That means such that. Alright. That's it. Work on your homework.
I don't remember any of that. We can finish. Yeah, let's go, boys.
Going up the best.
Alright, you guys want to go talk to Anna? See about the touch section? What do you mean?
789.
That's not as rich. Would it also be pronounced cow? And I think cow or tail. I know somebody with the first name Teo. No.
There's no way
You guys doing your midterm in that? Okay, so just, I can plug in. Midterm's well. Number 8.